Before I actually dive into the details, maybe just as a quick context. So, I've kind of now spent around 20 plus years in software. Last 8, 9 have been in the NLP space. Um, my own startup with the firms like again with Amazon, IQVIA, NatWest. Most of it has been in the conversational space. And currently, as Jacqueline mentioned, I am with a company called Stepstone, Totaljobs. Essentially, we are job recruitment marketplace. And for the last, whilst we've been working with NLP for a while, most of it traditionally was the KNN kind of models. But last 2 years have been extensively using LLM in terms of building conversational assistants. So what I wanted to share today was essentially the learnings that I've got. Some mistakes that we made, but by and large, these are practical things that I've seen and we've experienced. So hopefully this would be useful for anyone who's already in the process of building conversational agents or is starting off. That said, let's actually start off with a very quick. Let's take a step back and start off with a very quick high-level background. So, if you look at any kind of a conversational setup, this is my worldview. So you would obviously have the what, which is by and large what you're trying to do is essentially a multi-turn, a two-way kind of an interaction. This definition probably is true for a human-to-human conversation as well, but it's by and large, there's an element of context, there's an element of being very personal, there's a purpose to it, whether it's information retrieval or you're asking someone to get something done, but there's a what to it. And then there is a where, which is where are you having the conversation? So the channel to it in terms of whether it's mobile web, desktop, SMS, now RCS, telephony, any other place. Then comes in how are you having the conversation? Is it by text? Is it graphics, rich media, voice, video? So the multimodal element to it. Then who are you having the conversation with? Are you having a conversation with a human? Are you having a conversation with an NLP agent? Where then comes in the next piece in terms of once the intent is known, what do you do next? How is it being decided? Is it rules-based? Is it heuristics-based? Is it a model-driven? So the what next part of it. And then every conversation obviously will have some kind of data, whether it's canned information or whether it's dynamic information. So there you have the data layer. So this is by and large the framework or the ecosystem in which we work. And for today's discussion, what I'll do is I'll just focus on a small bit of it and largely look at it through the LLM lens. But my goal is by the end of this discussion, hopefully I would have kind of given you some insights in terms of which part do you want to use an LLM for, what kind of prompt engineering elements can you bring in, how do you design a conversation, do you need memory or not, what should you be testing for, which model should you be using, some technical decisions, and then I'm guessing a generic LLM advantage. So largely kind of the thinking process that we went through when we were kind of building these multiple conversational assistants. So let's get started. If you look at it from a traditional setup perspective, and again, this is one way of looking at it. There could be multiple ways, but every conversation you will have an initial part of intent detection. This is also where you're also extracting your entities, but largely this what does the user want through the utterance. Once you've understood what is the orchestration, then subsequently the part of it in terms of how are you generating the response. And traditionally, you would have it basically, you will have a rules-based kind of thing. You could have an NLP model. Your orchestration is largely that traditionally it had been where you kind of define a previous flow to it. So it's rules, heuristics based, and responses, whilst you have dynamic elements coming in, by and large are canned responses. So this is the traditional transformer, 2015 kind of a approach, 2018 kind of a thing. Now let's see how it might change in the LLM paradigm. So in the LLM paradigm, again, you can have three sets of combinations. One is traditionally, instead of using the KNN kind of models, you now kind of have the advantage of using LLMs or small language models as well, or various models. You could still decide that whilst because LLMs are fantastic in terms of, or any kind of large transformer-led language models are very good in terms of intent detection. So you say, hey, I'm going to just use it for intent detection. Once I know this, I know my path. It's basically, it's a very clear approach. So I'm going to still use heuristics or rules-based in terms of if this, then do that. And then I'm going to have a canned response. And I'll talk about where we can use this. But then you could basically go one step further and say, I'm going to use the model for not just for intent, but also for orchestration. This is where you've kind of almost given the entire script in the prompt or somewhere to the model saying, hey, this is what the conversation looks like. Your goal is to kind of get this information. So the entire conversation flow is not predefined. It is very dynamic. It's slightly open topic as well. But once you know what needs to be done, you're still kind of going for canned responses. And there will be some cases where you will still need a templated response, and I'll talk about it. And the third is where you kind of really entirely is LLM driven, where you have the model for intent, you have the model for orchestration, and then even the data that is, or the responses that are being generated, those responses are being generated by the model. And places where you would actually have these kind of come in is, as we kind of talked, as I mentioned earlier, you would have where you have a very defined, it's not a very complicated journey. So it's, I say shallow and not very complicated, because then otherwise your conversation graph will look very, very complex and very vast. So if it's a very shallow journey, defined flow, you don't want to spend in too much money, because remember, conversations or LLMs would cost money as well. You're okay to kind of go with a KNN. You don't always have to go for an LLM. Where you are again in the same breath, where again you're still looking at a very defined flow, shallow, utilitarian kind of an approach. You know what the conversation can be. You don't want it kind of too open-ended as well. That's where you kind of still stick to the heuristics-based canned responses. Some places where you might want to kind of allow for a more wider conversation, but you still need to kind of give back canned responses. And one example could be where you're dealing with compliance use cases. Over there, you cannot, because we know that LLMs or any of the language models by nature are stochastic in nature. So you can't actually 100% say that this is the templated boilerplate response that you have to give. Many times there will be variation. So where you're dealing with compliance kind of use cases in terms of whether it's GDPR or something where a canned response has to be given, that's probably where for those use cases you still, whilst you have a model to do the intent and the orchestration, once the what needs to be done is identified, you're still going with canned responses. And finally, you would have the more oftenly used use cases where by and large the user is looking for information. You're not too caught up with the idea of this is, you're still guiding it in terms of this is how the response needs to be given, but you are not caught up with the exact wording. That's where you kind of bring in the element of the model-driven conversation as well, or model-driven response generation as well. Let's go on to the next piece. Now let's talk a little bit in terms of the various kind of prompts that you could have. And I'm pretty sure when we all think today in terms of prompt, we just think of a single prompt, which is what we call as the monolithic prompt, where you've kind of got the model, you've put all your details over there, and you would have effectively a monolithic prompt. And I'll talk about some of the pros and cons of that, which is what led us to kind of try out two other approaches as well, which is where instead of having all the information in one single prompt, think in terms of almost like a microservices kind of a approach, where you have specialist agents, or you would even have LLM as tools, but you have, instead of having it all in single prompt, you have it broken down in terms of multiple agents or multiple chunks of the prompts, where each agent or each tool knows that, once it's done with its bit, who does it need to transfer it to, whether it's agent one, agent two, etc. So it's like a federated piece. There is no central orchestration, but it's a federated piece. Or you would have a variant of that where there is almost like a centralized piece where you have the primary agent kind of orchestrating, saying, okay, this is the intent, go to agent A. Once agent A is done, then basically it kind of transfers it back. And then that's how the conversation happens. Now, why go through this entire rigmarole of multiple agents is because and I'm pretty sure, when any of you kind of try out where you're dealing with an enterprise use case, you're really talking about fairly large prompts. And what happens is, whilst it's very easy and simple to kind of get started, many a times it is very prone to regression, because you would put this live, you will see a bug, you will fix one bit of the prompt, and inevitably there is no guarantee, and inevitably we've seen that some other bit of the prompt starts behaving slightly differently. It is more expensive because you don't want every time, whilst the prompt would have basically the instructions for 5 different cases, every time you don't need all that information going in. But because it's single prompt, every time you're basically sending out that entire large prompt, it's costing you tokens. It's also costing you in terms of latency. And equally, when it is that large, many times adherence to the instructions becomes a problem. So it's obedience to the guidance being provided was an issue, which is why we kind of we tried out the experiment in terms of the multi-agent tools part of it. And the federated approach, we started it off with that. Again, keep in mind, if you're starting off and if you're looking for a simple implementation, this is not for you. It's only when you have a good handle of what your flow could look like, you have a sense of what your agents will be, that's where you can actually bring this in. Because again, now what happens is every time it's only a very focused prompt that goes in. Because it's focused, it's quicker, less tokens, the obedience adherence is higher as well. But because it's multiple kind of interactions happening, the number of calls goes up. And as I said, this is only true for if you have a mature setup, if you know the various agents that you would need, that's when you build it. Again, the same thinking as a microservices setup. You only go for it once you have a mature setup available, or you know what needs to be done. And then finally comes down to, again, in the same vein, even the primary and the secondary approach, same elements, less expensive, more obedient. But over here, what happens is you can potentially make it more reusable, because what happens is the specific elements of, or the business rules, if you will, sit with the primary. And now you have very reusable modular agents, which you can at any point of time stitch differently. You bring in a different primary, different instructions, and it becomes far more reusable. But again, this is when you have a complex setup, when you know the kind of reusable components you need, that's when you kind of go for this. But it presents its own advantages as well. Let's go one step further in terms of the prompts. And whilst you have this, and again, a call out is this is just me, I've talked about 3. There could be various other ways of kind of, having the prompts as well. But in terms of the generation of the prompts, you could either do it manually, or you could basically, I do it from time to time in terms of I would kind of just ask the LLM saying, this is what I'm trying to do, generate a prompt. This is the model I'm looking for, and basically generates it. So you could have it auto-generated, or you could have the entire prompt manually written. You could also try, and this is again something that we tried, is basically you could also dynamically assemble it. Again, this goes to the same thing, that instead of having a monolith piece, what you now do is you first figure out what is the user looking for, and then at runtime, you are creating or assembling the most optimal prompt. So the size of the prompt goes down drastically. I think we kind of saw numbers as low as, basically, we kind of reduced it by 30%. In some cases, some complex cases, it'll probably be a 30 to 40%, but it's a significant reduction that you can bring about once you know what the intent is, and you're just assembling the prompt that is meant to just handle that particular use case, as opposed to, or that particular request, as opposed to the entire piece. And then obviously this is another thing, and people are experimenting with it, where you again don't even have the instructions in the prompt. You have a separate task, and based on the task, the prompt gets auto-generated. There are various ideas being worked out. One of the ideas that we are actually working with is almost very similar to test-driven development, where you could effectively have a test-driven prompt generated, where you initially write down your test cases, and then you are only writing the prompt that passes all those test cases so that you have it optimally generated. But this is by way of just letting you know that there are other options as well. It doesn't always have to be a single prompt. You could try different ways to kind of generate it. And many times you will actually get your cost and latency benefits from that. Let me go on to the next slide. And this is where you're kind of designing the prompt or designing the journey. In the case of the traditional KNN kind of setup, you would have it again, as we discussed earlier in the slide, you would have it almost defined as a flow. So you predefine the flow saying, if this happens, this is what it is. These are the various branches possible. So it's a very, very heuristics, rules driven part of it. When it comes down to the LLM, because, and especially if you're kind of going for the LLM driven orchestration, there would be multiple factors that come into play through which you can guide the model to follow a certain flow. And you could have it written down, you could have the instructions written down in the prompt, and I'll talk a little bit more about it. But you could also kind of give it examples. These could be static examples in terms of a few examples in the many cases. Again, a call out over here, many cases you might not need to give examples if it's a very generic nature. So it's a zero shot works as well. But in most cases, especially in the enterprise setup, you want it to behave in a certain way and you want to give it guidance. You would need the examples, and these examples could be static, as in they'll be a part of the prompt, but that increases the prompt size as well. Or you could have a dynamic where you're almost kind of doing a very shallow RAG kind of a thing in terms of, looking at the relevant examples and then it kind of behaving that way. You could have it kind of almost built into the model in terms of these same instructions fine-tuned into the model. There's an element where you need to kind of work with the temperature and the sampling in terms of, the top key and the top parameters over there. But again, temperature, I think if most of you are aware of it, it's basically, again, it's the how much creativity do you want it to be versus how much, how much do you want it to kind of follow the instructions. Zero temperature is better, but again, even zero temperatures, we've seen hallucination. Practically, it does kind of hallucinate, it does kind of deviate as well. But nevertheless, this is available to you from a parameter perspective. You could have the entire thing rules driven as well, which is where, again, it's very similar to the traditional setup. There's not much of an ambiguity to it. And obviously, there's an element of you are influencing the design through the feedback in terms of the continuous training and the things like, RLHF, reinforcement learning with the human feedback kind of thing, where there's a loop back feedback loop over there, where you're basically kind of continuously improving the design. So there are multiple factors over here, especially when it comes down to the prompt, which is, I think, the primary part of it. This is where you would put down your guardrails as instructions in terms of this is the topic you're supposed to talk about. This is not what you're supposed to talk about. You would have your base set of instructions. This is where you're also kind of providing the persona to the agent. You're providing the necessary context. You could be basically saying, hey, you're a career coach, or you're basically a headhunter, or whatever it is in our cases. And this is also where you would kind of almost have your high-level meta instructions in terms of maybe things around the GDPR, things around data access requests, anything to do with compliance, anything to do with things around around, especially in Europe in terms of the EU AI Act, any compliance issues. These could be a part of the meta instructions. So it's a combination of things, a combination of factors. Unlike traditional, where it's a very rules-driven thing, there are a number of things that you can play around with, just so that you can kind of get the model to kind of behave in a certain way, which is the designing of the flow of the conversation. In terms of the next piece is there's an element of, and this is again, depends upon how deep you want to go in and how mature your use cases or implementation is. But you will probably have to kind of play around with different kinds of memory. So for instance, if it's very contextual, it is very limited to that one particular conversation that you're having. You could have it, all the information sitting in the context window of the model. The moment the conversation happens, those instructions go away, the memory is lost. So it's a very short-term memory. You could also have kind of a mutable but long-term memory, which is something which is static, which is you could have the instructions. So I kind of talked about the dynamic examples, but you could have some of the instructions sit in a RAG setup. This is basically not lost after the session. This stays, but it kind of is. You can keep changing it in terms of as and when required. You kind of edit it, you add instructions, delete instructions, come up with better examples or whatever it is. So this is where the mutable part of it comes in. The permanent memory, obviously, is where you kind of almost built it in the model through the pre-training process, through the fine-tuning process. These are things that are going to hold true. You need it throughout, and you will not want to change it. So you're saving on your prompt tokens. and you're saving on your processing time, and you've kind of built them into the model itself. Then comes in elements of episodic memory. So this is very similar to how humans would remember you. You're having this conversation. You will probably not remember this entire discussion, but you'll only remember small bits of it. You remember small episodes, and these can then get referenced. So this is where you're kind of almost saying, okay, so the users kind of shared this particular information. I'm going to store it in a profile somewhere, or I'm going to store it in the logs, and then basically, as and when required, I'm going to just retrieve it later on. I talked about the continuous learning. This is the adaptive memory. There's a loop that kind of comes back and you're continuously learning. You could have basically the context getting augmented dynamically. This is where you are making the necessary API calls, and it's a combination of data inputs that you can bring in. And then obviously you have a very scripted memory where we kind of tell you what your memory is, because it's a very rules-driven engine kind of thing. It's a very static setup. So again, it's a combination. It's not one or the other. It depends upon, based on the data point, you can decide whether you need it to be only contextual or whether you need it to be long-term and it can be mutable. And that's where you kind of place the information in those places. In terms of, again, I'm rushing through this because I'm conscious of the time as well. But in terms of once you kind of build this or you're getting to this point, especially true for enterprise applications, because there are liability issues, there are responsibilities over there. You have to kind of put in a lot of effort in terms of a lot of thinking around the testing part of it as well. And testing for LLM agents is different from a typical software. I'm guessing all of you are probably already in the AI space, so this might already be known. But just to kind of re-emphasize, LLMs by definition are stochastic in nature. So just because you run a test and it passes once doesn't mean that when it goes live, it will pass again, or it will basically give you the same output. So there are multiple elements in terms of this variability to it. Especially when you're talking about prompts and these kind of things, they are highly prone to regression, and many times because it's a black box, it's not very clear in terms of what is causing it. So this is something that you need to be aware of. And because it's a conversation, you're testing it in the context of a multi-turn interaction. So it's not like a linear flow. It could spawn out into any different direction. So that's another element of complexity that you have to bring in. So we're talking, in this case, we're talking about functional. I'll talk about the non-functional elements as well. But in terms of the functional part of it, again, not very different from the way you would kind of deal with a traditional software. You would have your test data being generated. In this case, you could either have a human or you could basically have a model have these test conversations. In our case, because test again is an element of, there's a cost to it, we tend to kind of use the cheaper models, or we've kind of used the open source models in terms of the Llama class of models to kind of have these conversations. So they are kind of generating these or running these tests or having these test conversations. And test conversations would have elements of, have some scripted information, something which is kind of again dynamic. And then in some cases, you're not just testing for the happy path, you're testing for the edge cases and you're stress testing it as well. But nevertheless, once you have the transcripts, there are multiple ways to kind of go about it. I would say when you're starting off, there is no point in investing in, and especially if your volumes are low, there's no point in investing in having it automated. So we kind of started off initially with a manual review in terms of, hey, is this in line with what we're expecting it to do? But once we kind of had this running for a while, we actually went down the route of an LLM as a judge, where you have another model actually review the transcripts for whether basically whether it is kind of delivering what it is supposed to do or not. And then finally, you would have, just like any other software, you would have your UAT, and you would have your maybe almost like an alpha or a beta testing with some friendly customers or focused customers as well. The only difference is, as I kind of talked about earlier, is if you just do this once and if you're relying on it one cycle, it'll probably not work. So and I don't know the answer to this. We've kind of tried out multiple things, and I think in our case specifically, it's only after you've got a similar response after 4 or 5 times, you can do this. And there are various ways to kind of again test it in terms of you're testing for multiple outputs, and then you're kind of combining it as well. But it's basically, this is by way of saying it's an iterative process, not a single test cycle. You'll probably have to run it multiple times as well. In terms of in-life test, again, as we all know, there would be elements where there'll be model drift. You might actually bring in a different model, and therefore prompt changes will be needed. So there's an element of a spot test, spot checks that need to happen, or you basically again would have a manual or a model driven. You keep running those tests just to kind of check for the drift. One thing is, in terms of, again, this is true for testing, but even once you've gone live in terms of root cause analysis, I would strongly suggest the use of frameworks like Chain of Thought. We extensively use React just so that you're kind of getting a sense of why the model is behaving in a certain way, and otherwise it's a root cause becomes very, very difficult, and then you're guessing, and then it'll just lead to a lot of regression in from that perspective. When it comes down to the non-functional part of it, again, no surprises there. You would probably have something very similar to what you would have for any other software. So you would have your components of latency, throughput, scalability, availability. But over here, it becomes slightly different, is because you have the model endpoints which will contribute to the latency as well. And so therefore, this might initially influence your choice of the channel. So a case in point being, over here is when we started off, we were actually using GPT 3.5, then we went to 4, and even 4 Turbo. And for those of you who've kind of worked with these models, you will know that this usually, at least over here in Europe, we used to have kind of latencies of 20 to 30 seconds. That couldn't have really helped us with a proper web-based experience. And so therefore, we started with WhatsApp, which kind of allows for that slightly asynchronous nature. And it's only when we kind of got down to kind of using the models like 4 Omni, etc., that's when we kind of went in for the web chats as well. What has worked for us is, a 2 to 3 seconds latency on the web, 10 to 15 seconds latency on the WhatsApp. You don't lose, your drop-off ratios are not that high. Anything beyond that, I think, is worrying. In addition to these, now with specifically with the LLMs, you obviously have the additional factors to kind of bring in, which would be things like compliance. We talked about earlier in terms of things like GDPR, under 18, anything that is coming in from the EU AI Act as well. And the solution obviously is you would have focused intents for these in terms of recognizing when someone has put in a request for a data access, or someone's been put in a request to be forgotten, and based on that, once the intent is understood, there are subsequent actions that happen. I've put hallucination somewhere between compliance and ethical, but it's by and large a very fundamental part of LLMs. I think if you're working with that, you would have heard of LLMs, the hallucination being a key problem, especially in the enterprise setup. You need the hallucination to be brought down to fairly low numbers. I think it's going to be very difficult to, unless you're kind of dealing with static canned responses, zero hallucination is not really possible. But it's a question of what kind of hallucination are you happy with in terms of, is the fundamental data point being changed, or is it the way it is being presented is being changed? But by and large, towards countering hallucination, what has worked for us is, again, prompt tuning. You've kind of put in the instructions over there, you're fine tuning the model as well. And in some cases, you're also kind of giving guidance in terms of static and the dynamic examples. That's how you're kind of defining, saying this is where you're not supposed to hallucinate. This is where it needs to kind of give you a specific response. In addition to that, again, elements of toxicity, bias, naturalness as well. Toxicity, as we are aware. Again, I'll talk a little bit more about it, but this is a known thing. You have multiple endpoints. Microsoft has its own endpoint. OpenAI has its own endpoints. There are multiple endpoints available which will detect for toxicity, but you need to kind of allow for that, and you need to kind of check for that both from the user perspective as well as from the response model generation perspective, because it's an enterprise use case. Bias, the same is true. You want to detect bias in a loaded question that comes in from the user saying, is this job good for an Asian male? There is a bias involved in that. So you need to be able to recognize and sidestep that. And of course, you want to make sure that any response that comes in from the model side does not have bias included in that. Again, same things, you're making sure that you are kind of providing the necessary examples, good and bad, in terms of the static and dynamic examples. You're providing instructions in terms of the prompt and the fine tune. And then overall part of it, there's an element of the naturalness to the tone in terms of, and there are various aspects and we kind of use to define naturalness. I'll talk about subsequently. But this is some of the key non-functional elements that we've kind of focused on and we've tested. And the reason why I keep saying we and we are doing this is because I'm conscious that there is no playbook. So I'm giving a sense of one of what has worked for us. That is not to say that this is the only way to do it, but at least it kind of gives you something to kind of get started off with, and then you can build on it. In terms of testing, no different from what you would do from a functional perspective in terms of that entire cycle. But what we do is, whilst we do a prevention through the prompts and the examples at runtime, there's an element where we've again got LLMs as judges, where we have models, again, cheaper models, to kind of go through the transcripts on a daily basis to detect any leaked hallucination, any leaked bias, toxicity, basically rated in terms of naturalness. And then you could either have a human or a set of people who would kind of do this. But again, as you scale up, it's very difficult. So that's where having a model kind of review the transcripts helps. And then you basically kind of get down to the part where your conversational analysts actually review the reports rather than they're kind of going through the entire review part of it. And it seems to be working for us. So this is one approach of doing that. I talked about a little bit about toxicity, naturalness, empathy. Why is it important to kind of break it down into specifics? Is because, especially if it's a human, it's almost like it's tacit information. You know what a natural conversation looks like. You know what an empathetic response looks like. But if you're actually going to have a model test for naturalness, test for empathy, you need to break it down into some factors, and then you need it to kind of rate it based on that so that you're getting the transparency. So without going into the details, this is one way of doing it. This is a framework that we've come up with, where when we are basically rating something in terms of naturalness, we look for coherence, we look for engagement, human likeliness. Is it following the grammar? Specifically, especially if you're kind of looking for a multilingual use case. So for instance, it could be English, German, French, etc. It might be good for one language, might not be that great in other language. Even tones matter in some languages. So that's where you're looking for the naturalness over there. But again, this is one set of data points to kind of one set of factors to kind of work with. Different models can have different aspects to it. So that's essentially the non-functional side of things. Let's get into probably a question, and there is no real ready answer for this in terms of which model should you use. It depends upon what you're dealing with. And I'm guessing it's like you will have, and I'll give you what we've done, but one pressure I think all of us as AI PMs will have is it's like literally every week there's a new model coming out. So, what do you do? How do you set yourself up so that you have the ability to kind of change models as and when required? And so that's where the swappability kind of comes in. But when it comes down to the models, there's an element of, you have a few decision points. So for instance, do you use a proprietary model? Do you use an open source or open weight model? The answer is it's always easier if you kind of just go for a proprietary model. And it's by and large very engineering led. So if you have an engineering heavy setup, you don't have a lot of data science, firepower, start off with a proprietary model. Always easier, always quicker to basically try and just test for that product market fit. And only once you've kind of got to that point, that's when you can bring in the open source models, or you're basically fine tuning your other models, etc. So it depends upon what stage you're at, and the element of the resources that you have, and the nature of the setup that you have. Should you go for a generalized model versus a specific model, specialist model? Obviously, always better to go with the specialized models, but they come at a cost, and it also depends on whether do you really need it, how deep, how domain specific is your use case. Again, the advice would be start off with the generic ones, test for your product market fit, and then if required, go for the specialist models. Do you go for the traditional versus the LLM approach? Again, it depends upon how much time to market do you need. LLMs, because you really don't need to kind of train it upon intents and entities, etc. It's quicker. What would have required maybe 3 months of training for it to kind of get to the right containment ratio. In the traditional setup, now you're literally talking about, weeks, if not days. So it depends upon how much or what ability do you have to train it, and the time to market timelines. You could always, again, preference would be to start off with the LLMs, and then if required, what I'll talk about is you could potentially have a mix and match as well. Other factors to consider is obviously the model size, depends upon the complexity. If your use case is not that complex, small language models work out well as well. So based on your complexity of the use cases, choose the model size. Accuracy and performance, again, very logical, driven by the user profile, how open, how complex is your use case. Latency, as I talked, is based on the channels that you need to support, in some cases the other way around. But based on the channels that you need to support, you then need to kind of pick up a model which provides the necessary latency. And obviously, there's a big factor of cost. Keep in mind, obviously, now the costs have been dropping drastically, but nevertheless, this is an additional cost line item that kind of comes in terms of the token costs, unless you're you got your own model, and most of the cases, the proprietary models will provide an additional cost. So it's important to kind of start off with the business case, figure out what North Stars, which needles are you trying to move, form a sense of the ROI, and then work backwards in terms of from there, in terms of can you actually afford to have the LLM, and are you kind of generating a healthy ROI? One word of advice over here is what we kind of talked about. I referred to this earlier as well. We actually have a multi-agent setup, mainly because it allows us to almost do mix and match. Whenever we are trying to kind of bring in a new model, we would just bring it for one of the agents, see the additional work that is needed in terms of changing the prompts, etc. Also, because you have it as a separate entity or a modular entity, it localizes the thing. That doesn't cause wide regression as well. So if you can go down that route, always a good idea to kind of have a mix and match on a multi-agent kind of a setup. But again, it's not what you start off with, it's what you kind of graduate towards. And it's again a function of the simple. If it's a very simple use case, you might not even need multi-agents. You're probably fine with a very small monolithic prompt. But in that case, you don't get you probably maybe will have to do it based on the environments, in terms of, for this environment, I'm trying out, GPT-4 Omni Mini. And for this one, I'm trying out maybe a GPT-4 Turbo or something like that. Then it comes down to some of the technical decisions. Again, one important one is the hosting. Whether you go cloud hosted, on-premise, or a hybrid, depends upon essentially the data that you're kind of dealing with. Cloud hosted, obviously, the advantage is the fastest. You basically are using an Azure endpoint or XYZ endpoint, and it's cheapest, very quick. However, if you're dealing with proprietary data, and especially if you're doing it for maybe an external customer, this kind of needs to come into picture, and they might actually insist, if it's a bank or something, so they might actually insist that you basically have an on-premise setup in terms of, strict data compliance requirements. But again, keep in mind, whilst in the case of a cloud setup, you don't have to have a lot of expertise in terms of maintaining the models and maintaining the infrastructure. Over here, there's a significant in-house expertise that is needed. And in some cases, you would basically allow for a hybrid setup, where you're basically, again, typically if you're dealing with a SaaS kind of a setup, some bits are cloud hosted, some bits some information stays within the enterprise setup as well. And then in addition to that, you would have your typical use cases in terms of, or typical things to worry about in terms of load balancing, whether you do horizontal scaling or vertical scaling, performance monitoring, all those elements in terms of cost evaluation, analytics, the typical bits. And then I think I'm down to, if I'm not mistaken, my final slide, which is where we're actually talking about potential advantages. And I think it's an open secret. Obviously, why do you use LLMs? Because they're generative, they're very natural outputs. takes the level of the conversation to a very, very high level. Obviously allows, because these are large models, they are open topics straight out of the box. You can just plug something in and it'll basically kind of get you started. You don't need to kind of pre-train in terms of the intents. But things to call out is, especially if you're trying to kind of, when we've been trying to build in stickiness and, higher engagement, if you can experiment with the multilingual part of it, which the models are very capable of, it adds to that element of stickiness. So multilingual is a very strong element to kind of leverage. Multimodal to the extent that it is required, if it is a valid use case. So for instance, if it requires, some kind of a maybe an interview process or something like that, in our case, etc., maybe a multimodal use case with the visual elements kind of comes in handy as well. And obviously, one aspect is, I've been building software products for a while, and for a majority of it, we don't really account. We keep it very functional. We don't account for the emotion part of it. I think now with the LLMs and with the conversational piece, you can actually go after the emotional support, account for the emotional response from the user, and instead of sidestepping it, build it as a part of your product. So this is another key piece over here. And then in terms of, what the future holds, I think there are new models coming out for those of you who've been following. Obviously, there are OpenAI has come up with a new reasoning model. Small language models are going to become big in terms of on-device models. Kind of smaller models work out well. You would have specialist models. I think gradually you'll kind of get down to the point now most of the models can be fine-tuned. Fine-tuning again helps if you really need it, and you want to kind of differentiate and you want your model to be very specific and trained on your particular kind of data. And then there are various other aspects that would kind of come in terms of the regulatory aspects, in terms of, whether again, open source or open weight models are coming in big. So there are a number of things that are going to be happening in the space. But yeah, some of these you'll see specialist models come out. You will see multilingual models come out. A lot of the work hopefully happens in the open source space as well, which you can start leveraging. And then obviously keep an eye out on the regulatory setup, especially in geographies like Europe, where there's a lot happening in that space. So I think I rushed through it, but I don't know, Jacqueline, how much time I have. But
You're
hopefully,
perfect. We have around 15 minutes.
okay, wonderful. So hopefully we have enough time for questions. But yeah, back to you, Jacqueline, for the questions.
Of course. So this is the part of the presentation where we have around 10-15 minutes to ask any questions. So if anyone wants to quickly unmute themselves and ask a question or type it below in the chat, that would be great. I do see some questions here in the chat. Okay, so here is one from KV. So can you please talk about a sample use case that you and your team worked on and what were 2 to 3 key learnings?
So, I'll talk. So, one of the use cases that we've, there have been multiple places where we brought in conversation. But one use case was where we actually, because we are in the job tech space, we actually created a WhatsApp job search companion, where literally you can actually, so we kind of send out an alert, a daily alert to you saying, hey, KV, we actually have a job which might be a good match for you. And then you have a conversation with us in terms of, are you happy with the job, or you kind of on the fly refine it saying, I'm looking for something in the same space. It's a product manager role, but I'm looking for a higher salary, or I want to work in one particular place, etc. So there's an ongoing conversation, and you're refining it with the on the fly for the user. The underlying insight over here is when you're looking to get more data from your user, whether it's the KNN or whether definitely in the LLM, conversation always helps, because you're almost kind of getting one bite of information and you're gradually building it. So your drop off is not, instead of getting them to fill up a form where the drop offs are fairly, completion ratios are like 1% or 2%. When it comes down to a conversation, you would actually see a completion ratios of like 13-15%, some cases where 40% as well. So this was a use case where we basically where we built up a job search companion over here. And some of the learnings were So we actually started off with a human to human just to check whether there is a need for it. And one key learning, which is surprising, is we actually got a higher empathy score in terms of the CSAT with the model compared to the human. So when instead of a human chatting with a human versus the candidate chatting with a bot, counterintuitive insight was that they rated it higher in terms of being empathetic when it was the bot on the other side. And our hypothesis is because it's consistently, empathetic, a human can get worn out, but a bot is not. So this was one key learning that we kind of picked up. The second one was the element where discoverability is still a key issue. So you can build in a lot of features in it, but because the users actually have that notion of probably coming in from the time when the bots were not really that great, they really don't push it that much. So being able to kind of almost surface your features and guide them was one big challenge. We're still working on it. And one of the things we did is we used a combination of buttons and the quick actions just to kind of surface those and then drive those pieces as well. There are places where we kind of, based on actions, we kind of then would reach out and try and surface those features. There's an onboarding piece as well, but user education is something which gets missed out because it's not the jazz thing. But this is one key aspect that we basically we had to kind of work around piece. And then the third piece was the amount of issues that we actually had with the testing part of it, because as I said, stochastic in nature. So we initially kind of started off with a monolithic prompt, went down the route of the regression, then kind of obviously pivoted to other pieces. So the focus on testing, so if I had to do it slightly differently, the focus on testing, which was almost like a reactive piece for us, I would have kind of put in a lot more effort in terms of having the test setup built, having those agents built and done differently. So I don't know if that answers the question, but I guess these would be three key things which I hadn't thought about, or insights when whilst building this one particular use case. But there are other cases where we've built an interviewer, we've built other places as well where the conversational journey comes in.
Amazing. I think we have time for one or two more questions, so let's get through that. Again, feel free to leave any in the comments below. Okay, so here's a question for you. Could you please let us know more on how you built the recommendations engine for this WhatsApp job recommender product?
Yeah, so without going into details, actually, we leveraged the recommendation engine that we had for the site already, because ultimately on the website as well, there's a search engine, and we have different homegrown algorithms for that in terms of various parameters that get used. So I won't kind of go into those details, but long story short, we actually didn't kind of invest in the recommendation engine. Because it's a website already and people kind of come in terms of, they put in their what and where search parameters. We use the same backend. However, what we did, and we've kind of gone one step further, is we kind of went into the semantic search part of it, because now what happens is with the conversational piece, you're not just getting a what, where, but you're getting a number of additional parameters as well. So that's kind of almost that forced the push towards the semantic search, which we're basically working with. But short answer is we didn't have to build a separate recommendation engine. And that's the idea, that you're working in terms of the user experience part of it, rather than foundationally, you can use a lot of the foundational tech that already exists.
Perfect. Alrighty, I think we have time for one more question. So let's see. Anyone also is more than welcome to unmute themselves and ask a question verbally if they want.
Hi, this is Vaibhav here.
Yeah.
Mr. Biswas, how do you evaluate the efficacy of these conversational AI models? Is there like specific metrics that you use to find? Yeah.
It's a great question. This is like, I mean, ultimately we are all PMs. If we can't measure, we can't improve. So so that's where all those parameters, the test that I talked about. So for me, the way it would be is ultimately you're building a conversational experience for a particular business case. So you need to kind of start off with what your North Stars are. in terms of me, by having this conversation, have I increased the number of applications or have I increased the CSAT, etc.? So you'll have your North Stars, and as you're kind of, releasing features, etc., you're kind of checking, keeping an eye on whether those North Stars are working. But in terms of fundamental, we would have the daily checks that happen in terms of things like hallucination, things like bias, things like toxicity, things like naturalness. So those are the functional aspects that we kind of look for. And then maybe by bringing a new model or by changing the prompt, naturalness goes down. And because we don't have these as playbooks, it's almost like you start off with your initial benchmark and then you're following a glide path. So it's not that you're kind of going for a 5, maybe things like CSAT, there are parameters that exist, but in terms of naturalness, we initially had a scale of 1 to 5, then we went for a scale of 1 to 20, and then now we are back to a lower scale. So you're kind of experimenting with this, but you are checking for, is your conversation natural? Is there any element of bias? Is there any element of hallucination? If there is hallucination, is it foundational in terms of data, or is it the way it represents itself? So one thing I'll tell you, we've actually found that the model actually tends to, obviously it has a tendency to please the candidate. So it will actually make stuff up in terms of its capability, saying, yeah, I can give you a call at 12 o'clock on Saturday if that is better for you. So it makes stuff up. So you're checking for these hallucination elements as well. But short answer would be, yeah, you're basically checking for your business metrics, you're checking for your functional metrics, and the non-functional pieces. And then additionally, you're checking obviously from a latency and cost perspective. So you will have these various parameters that you're checking for. Does that answer the question?
Yes, thank you.
Perfect. And also everyone will get a recording of the presentation after it is over. I see someone is raising their hand here. If you'd like to unmute yourself, please go ahead.
Hey, thank you. Thank you, Jacqueline. Hey, Som, excellent presentation. Really loved it. I have more of a background question, not so much on the presentation. Could you speak a little bit about how you went about your journey as you transition into the world of AI ML? Like, how was it self-learning?
How did
Was
it
it
start?
Yeah.
Yeah.
And how did you swim? A lot of us are in this mid-career path where we're transitioning into the world of AI, and there's just so many options out there.
Yeah. So I think mine is it's a very boring story. It wasn't I started off in AI because I wanted to get into AI. Actually, it's the foundational piece. So this actually started off when I was doing my own startup, and we were the idea was to kind of make the enterprise services available on social media platforms. That was the premise of it. So instead of getting a candidate to kind of go to an enterprise's site, which requires ad dollars, the premise was that you already have people on Facebook and Twitter and this thing. So why not make a telecom service available? And we initially started off with something in terms of something called smart stickers, and then chatbots came in. Facebook opened its platform for chatbots. That's where we made a first transition into because it was the easiest way to kind of meet our vision. We started off with chatbots over there. And then I'm talking 2016. So at that point of time, the bots were not really that great. So I've kind of almost lived through this. So I've seen the times when you almost have to convince someone that a chatbot is good. Now it's the other way around where people come and ask you for chatbots. But I started off with that. But I think the underlying question which you asked is in terms of, the AI journey. Two words of caution over here, and this is my personal view. So, feel free to disagree. I think whenever I've heard people talk about AI PMs, there's a heavy focus in terms of data science, in terms of, hey, you need to know these models and all those aspects. And I fundamentally disagree with that. I think what has happened is now, because of things like from a prompt engineering perspective, it has actually democratized a lot of the AI. You don't necessarily need a data science team to start off and build a decent enough conversational agent, because you have these endpoints. And even with engineers with a fair amount of understanding purely from a prompt perspective, you can actually get started off with that. When I started off with my startup, when I started off in NatWest, even over here, when we started off, we actually just from 0 to 1 or 0 to 0.5 or whatever it is, you don't really need a data scientist, because these are large language models are there. You can start off with that. Yes, you need prompt engineering to put in the guardrails, but you don't need to do that. What would help When you get into the part of the data science part of it, again, you're not expected to know the models. Otherwise, you're doing the job of the data scientist. What you are, however, expected to know is literally the confusion matrix, in terms of you're basically saying, hey, I need a high recall on this one because this is to do with compliance. So I really cannot allow for any, false negatives. You have to kind of get everything. I'm happy to deal with false positives. I'll do something around it, but you really need to get a high recall, or you need to kind of get a high precision. So that's the extent. We as PMs are responsible for the product and the business outcome. If you're able to translate that and in clear terms to the data scientist or to the engineer, your job is done. That's my view. And I'm fairly confident of this because I've seen this in action over the past 8-9 years. Only when you kind of get to the point where you're really getting into fine tuning, or you need a different model which is not there, or something needs to be built bespoke, that's where you're getting into the data science world. But otherwise, straight to your business case, straight to your journey, and then know where to bring in. Is this a classification exercise? Do I need a model over here? Do I really need a conversation over here? If yes, then start over the endpoints. I don't know, Chetan, if that helps.
Thank you. That did help.
Amazing. Awesome. And we actually ended right on time. So this was great timing. I really appreciate it. I learned so much today. I really hope you did too. This was such a great conversation. So huge thank you to everyone for taking the time. And don't forget to join our 8 cohorts for product management in AI. You can learn all about navigating through the AI rabbit hole in PM, the next generation of technology companies. So I'm going to be putting the link in the chat so you can easily view that at your own